So when it comes to numericals, this one law is going to help us a lot. It is any kind of collision we are looking at, the momentum is conserved. So let me explain it this way. Say we have two objects with mass m1 and m2. They collide. At the time of collision, the force of F21 and F12 is observed. So these two forces are equal in magnitude but opposite in direction. This is as per your Newton's third law, right? Now, so let me assume one more thing over here. Let duration of collision be delta t. Now, first thing is, let's start off with change in momentum, or you can do this also. Now, let me express change in momentum. So we are looking at, say, object 1. So delta P1 should be equal to F12 times of delta T. When it comes to object 2, we have delta P2 is equal to F21 times of delta T. Now, this is the change in momentum, right? So momentum changes with force times of time. The amount of change happens, that will be equal to force times of time. So basically, when we apply force, the object accelerates, there is change in velocity and thus change in momentum. The amount of change depends on how much time we are applying that amount of force, right? I hope you guys remember the formulas. So now, as per the Newton's third law, what do we have? Well, we have F12 should be equal to minus F21, right? So if I multiply, multiplying delta T on both sides, what does it lead to? So we have F12 delta T is equal to minus F21 delta T. This is nothing but delta P1 and this is delta P2. So if I rearrange, delta P1 plus delta P2 will be equal to 0. What does this mean? This implies that there is no change in momentum. So all of this is equal to 0, is it not? So, or I can do this also. Integrating with respect to time on both sides. Okay. So we end up with P1. Okay, sorry, all these are in vector form. Plus P2, which is equal to integration of a constant. Sorry, 0 is a constant value. And so you can see that P1 plus P2 is equal to a constant. Okay. So again, the momentum, we have seen the conservation of momentum before. So you need to understand that in any kind of collision, elastic, inelastic, whatever it might be, the momentum is conserved. And we can use that fact in many numericals. So yeah, this is the proof.